Okay, lesson 22 is numerical expressions, sentences, and then conditional equations, which we'll get to in a minute. The first thing we should do is talk about numerical and algebraic expressions. Now, here's an example of a numerical expression, 7 times 8 plus 3 divided by 11. Here's an example of an algebraic expression, 6x minus 12 times x plus 5. The difference between the two is the algebraic expression has variables. That's what makes it algebraic. This is just a regular numeric. This one has variables, so it's algebraic. That's the only difference between the two. Now, the other thing we should point out here is in English class, we could say things like the number of oranges is equal to the number of apples. The number of oranges is not equal to the number of apples. There are more apples than oranges. Okay. Well, in math class, we have symbols that do that for us. So the number of oranges is equal to the number of apples. Number of oranges is equal to the number of apples. Number of oranges is not equal to the number of apples, and number of apples is greater than the number of oranges. We have more apples than oranges. So in math class, we could say the same exact thing as we do in English class, except we have symbols that allow us to do that. Okay, let's go to the back and see where we're going with this. We have these things called conditional equations, and conditional equations are only true if the conditions are met. For instance, we have 5 plus x equals 9. Now, we're going to solve this for x. So 5 plus x equals 9. Let's bring the 5 over here, subtract it. We have x equals 4. Okay, so the condition that solves this equation is x equals 4. That's the only condition that solves this equation. X can't be 3, it can't be 5, it can't be a billion. The only thing it could be is 4. Now, as we're going to find out here in a little bit, sometimes there are more than one condition that can exist to solve an equation. Like this example here, we have 4 plus x and 2 plus 2 plus x. Okay, well, 4 plus x over here, but really 2 plus 2 is 4. So this side also says 4 plus x. Since the exact same things show up on both sides of this equation, I can plug whatever I want in for this x, and I'm going to get the same thing on both sides. It could be 3, which is going to be 7 on both sides. I could use a billion, which will give me 1,000,000,004 on both sides. It doesn't matter. So we say any number will satisfy the condition. Number 2, 7 plus x equals 12. First thing I'm going to do is solve this for x. Bring this over here, subtract 7, and x equals 5. Now this is a conditional equation where the only solution is 5. It can't be 6, it can't be 4. It has to be 5. Okay, and number 3 is another example where there's only one answer. Bring the 8 over, divide by 8, and we find out that x is 2. The only answer for this one is x equals 2. Now, as we're going to find out in number 4, there's a third option for these conditional equations. So in number 1, we had many solutions. In 2 and 3, we had only one solution. Now, in number 4, we're going to find out that there's a chance that there could be no conditions that satisfy the equation. Take a look at this. We have 7 plus x equals 9 plus x. Well, if I take this x and bring it over here, that means I would have to subtract it. X minus x means there's no x's left. That's 0x. So what I'm left with is 7 equals 9. Which makes no sense whatsoever. Since this base equation here does not work out, there's no possible number I can plug in here for x to make this make any kind of sense. So here we say there are no solutions. At the bottom, basically what we're doing is just plugging in numbers to see if we can find these things called roots. And what roots are are solutions to conditional equations. They're called roots. So we're going to try number 1, and we'll see if 5 or 2, negative 2, works for this equation. If it does, it's a root to this equation. Alright, so we have 5, plug it in for x, that's 5 squared is equal to negative 5 times 5 minus 6. Okay, 5 squared is 25. And let's see if that's equal to negative 5 times 5, which is 25. Negative 25. Negative 25 minus 6 is negative 31. That does not work. So 5 cannot be a root here. Let's try negative 2. We have negative 2 squared is equal to negative 5 times negative 2 minus 6. Alright. Negative 2 squared is 4, so what we need to do is see if this goes to 4 over here. And if it does, then negative 2 works. Negative 5 times negative 2 is positive 10. 10 minus 6 is, there's our 4. So negative 2 is a root. 5 is not. Okay, we'll try the other 3 examples together in class. If there was anything that you thought was confusing, make sure you go back and rewatch that section of the video.